Hello, welcome back once again. Today we wish to evaluate the 24th power of root of 24 divided by the root of 30 plus root of 6. In this video, I'm going to show you guys how we can easily solve this problem using the idea from a great mathematician known as Fibanocci. So here we're going to simplify this which is in the brackets a little bit. So we have here the square root of 24, then divided by, we have the square root of 30 here, plus the square root of 6. So up here we know that the square root of 24 will be same as square root of 6 multiplied by 4, divided by, down here we have the square root of 6 multiplied by 5, plus the square root of 6. So this will be equal to square root of 6 here multiplied by square root of 4, divided by, here we have square root of 6 multiplied by square root of 5, then plus square root of 6. Okay, so up there we have, this is equal to square root of 6 multiplied by, we know square root of 4 is 2, right? Then divided by, down here we can factor out square root of 6, which is common, and we'll be left with square root of 5 plus 1. So this cancels this, and here we have this equals 2 divided by 1 plus square root of 5, right? And if you take a look at this, you will see that this is just the reciprocal of the golden ratio, right? Cool. So our expression now, which is square root of 24 divided by square root of 30 plus square root of 6 whole raised to the power of 24 will be equal to 2, right? So we have 2 up here. So we have here 2 all over 1 plus the square root of 5 whole raised to the power of 24. Let us recall about the golden ratio, right? We know that 1 plus root 5 divided by 2 is just equal to the golden ratio, which is approximately equal to 1.618. This number is very, very important in mathematics and science. It appears almost everywhere. Okay? But today we wish to evaluate the 24th power of its reciprocal. Then let us recall the following formula from our great mathematician Fibanocci. We have that the reciprocal of that is the nth power of the reciprocal of the golden ratio, which is 1 all over phi raised to the power of n. Phi here is the golden ratio, that this is equal to -1 raised to the power of n into bracket the nth plus 1 Fibonacci number minus the nth Fibonacci number multiplied by the golden ratio. Here n is greater than or equal to 1. Interesting. So we're going to use this amazing formula or identity to find the 24th power of the reciprocal of the golden ratio. Here f of n is the nth Fibonacci number, and we know that f of 0 is equal to 0, right? F of 1 is equal to 1, and then most importantly we know that f of n is equal to, should I call it a recursive formula, f of n minus 1 plus f of n minus 2. For this part here, n is greater than or equal to 2. Okay, so let's see how we're going to use this idea to solve this problem. Remember, we have that 1 all over the phi to the power of n is equal to negative 1 to the power of n multiplied by f of n plus 1, right, minus f of n multiplied by the golden ratio. Okay, now let us list some or few of these Fibonacci numbers, right? Firstly, we're going to start with 0 and 1 as first and second term. I hope you get the idea. So let us start like this. We have 0 as the first term, we have the next term as 1. Then for us to get the third term, we need to add the first term and the second term, which is 0 plus 1, that will give us 1. For us to get the fourth term, add the second term and the third term, which is 1 plus 1, that will give us 2. The next term, add 1 plus 2, you get 3. The next one, 2 plus 3, you get 5. The next one, 3 plus 5, you get 8. The next one, 5 plus 8, you get 13. The next one, 8 plus 13, you get 21. The next one, 21 plus 13, you get 34. The next one, 21 plus 34, you get 55. The next one, 55 plus 34, you get 89. The next one, 55 plus 89, you get 144. The next one, 144 plus 89, you get 233. Hope I'm right. So you get 233. The next one should be 377. The next one should be 610. The next one should be 989. The next one is it 989 or 987? So that should be 987. Sorry. So this one here is 987. So 987. The next one 1597 or 77. Okay, that 97. Then 2584. The next one 4181. The next one 6765. The next one, that is 109, 946. The next one 17711. The next one 28657. So we have 28657. The next one we have 46368. The next one 75025, and so on. I was able to list like about the 25 of this Fibonacci sequence because we have a power which is up to 24 right over here. So now using this above formula here, we have here 1 over the golden ratio to the power of 24, which we're asked to evaluate, is going to be equal to the f of 24 plus 1, which is 25, minus the f of 24 times the golden ratio. So you can see the reason why I listed like about 25 of these numbers. So if you check properly, the f of 25 is exactly this one right over here. So that is 75025 minus the f of 24. The f of 24 in this case is exactly, we have 46, yes, this one right over here. So 46368, then multiply by the golden ratio. So all we need to do now is to do our nice simplification. So we have 1 over the phi to the power of 24 will be equal to 75025 minus, so we have 46368 multiplied by the golden ratio, which is 1 plus root 5 divided by 2. So this is equal to 75025 minus, so you need to divide this with 2, so that will give us 2, right? Then we have 33184. So we have 23184 into bracket 1 plus root of 5. So from here now, this will be equal to 75025 minus 23184 minus 23184 times root of 5. Simplifying now, we get this is equal to 51841, right, minus 23184 times the root of 5. And this is our right answer. So now we can say that square root of 24 all over square root of 30 plus square root of 6 whole raised to the power of 24 is exactly equal to 51841 minus 23184 root 5. And this is the correct answer. Thank you for watching. Please, if you really enjoyed this video, kindly subscribe to my channel, and please do not forget to like, comment and share.